Okay, so last time we discussed actually centroids and moment of inertia. We started examples related to moment of inertia, specifically on transfer of moment of inertia. This is very important, especially in some design problems that we are going to analyze in the next sessions. Okay. Okay, so okay. So just a recap, okay, for us to remember what I'm talking about, transfer moment of inertia. For example, here you have a certain area here, and there's an area, and you get a centroid. This is the centroid. Here I'm referring to a differential area, part of that area, differential area. Then the centroid of that, okay, to that particular area. Let's say, mas madali, ano, it is a rectangle. The centroid is over here. Okay. Now with this rectangle, you're going to transfer it to X. The centroid of this area is XO. Now, if I'm going to get the moment of inertia with respect to this X-axis, then I am going to transfer this local neutral axis, or the neutral axis of that area or this area. I'm going to transfer it over this axis. This one is very evident sa mga built-up designs. Okay, sa design, especially in steel structures, a combination of angle bar and the plates that form a I-beam or a T-type structure. What possible structures that we use in structural steel design? Okay, so we transfer using this formula. So the moment of inertia with respect to this XO, yung local neutral axis natin, or for example, ito rectangle, ano, itong neutral axis niya, the moment of inertia of rectangle, let's say, just review, B D cube over 12. If this is B, this is D. Okay. Now, we get the area of this rectangle, as we all know. Area of rectangle is just B times D. Okay. And then this particular distance from the center of this rectangle, or from the center of this area, going to the X, or to this axis. Okay. So there is a distance that we can determine and a very specific problem. So we have this D to the power of 2 and then area. Then we can get the moment of inertia with respect to X. In other words, we have the moment of inertia in this axis. If we are going to transfer it over here in this X axis, will be different. The purpose of this one, as I said earlier, sa mga specific structural steel design structures, mga I-beam or even some other structures na halimbawa may mga hindi available, you need to have a belt up, then you have to do with this transfer of moment of inertia. Just like this one, example of property of structural section, an angle bar. Okay. Anyway, during the exam, these properties are given naman. Okay. So you have here the size, for example, 5/3 by 1/2. This is the area. Ix with respect to, for example, this one, as you can see here, for angle bar, ito yung XO niya, okay? Or yung axis niya. Okay? So distance here, going here is XC, this one is YC. Okay? In other words, then you are going to have a belt up, pag ginawa mo siyang ganun na, okay? In this direction. So that makes a different orientation. That you have to remember that the original orientation of this angle bar is the longer side of the leg is in this side and the shorter is here. That's something that you have to remember, especially during the exam. And then IY also, IX, the moment of inertia with respect to this axis. IY, the moment of inertia with respect to this Y axis. XC, as I was saying, the distance from here going here. YC, the distance from here going here. Okay. For channel, the orientation is here. Right? Something that we have to understand. Okay. And if it's given in the problem in the board exam that you have to understand well, you have to understand well in the diagram or the drawing that is being shown. For example, here, a girder is composed of a 4 6 by 6 by 1/2 angle. So ito yung apat na, these are the 4 angle bars, 6 by 6, equal legs. 1, this one, 2, 3, 4. Okay, and then you have here a web plate, ito, which is 23 by 1/2 by 1, plus 2 flanges, ito, flange, ito then flange. Okay. Now, as if you can see here, this one is 24 inches. The size of our web plate is only 23 and 1/2. So in other words, may gap siya dito, no? So there's a gap here. Which this one is 24, this one is 23 and 1/2. Okay, meaning this one is 1/4, this one is also 1/4. Which this is very important when you are going to get the transfer of moment of inertia for this one. Okay, the centroidal angle bar is here. Okay, now you're going to transfer here over there. This one will be the D that I was referring to earlier in the previous slide. Okay, so all are given. To flange, the plate, the flange is 18 by 1. Okay, and then you have the properties of the angle bar. This one, this angle bar, IX and IY are the same kasi nga they are equal legs. Area is given, X and YC is also the same, are the same because they are equal legs. The question is to compute the moment of inertia. Okay. This is the moment of inertia that we're going to compute with respect to the centroidal x-axis. Okay, the centroidal XO axis. What I'm saying, this one, this is the XO. The centroid here is given, it's already here. Okay, but the centroid of this angle bar is here. You are going to transfer it over there. Okay, so we can do it by tabular computation, or we could do it also individually. It's up to you how you're going to do that. So the formula that we're going to use is this one. Okay, so first for the web plate, this is the web plate. Okay, this is a web is rectangular, right? This is 23 by 1/2. Okay, again, this is 23 by 1/2. Okay, 23 by 1/2. 23 and 1/2 by 1. Ang haba niya, the height is 23 and 1/2 or 23.5. The formula is BD cube over 12. B is 1 inch, this one, 1. This one is D, the depth is 23.5 over 12. And then the area of this one, if you're going to use the transfer formula, but actually, logically, you're not going to use this transfer because you don't need to transfer because the centroidal axis of this web plate is coinciding with the XO or the centroidal axis of the whole structure. But this calculation just to show that there is no D. That's why D here is 0. Okay, so we calculate it. It becomes this answer. Okay, how about the two flange plates? These are the two flange plates. This one, okay, this is the flange 1 and then flange 2. Just need to calculate 1, multiply it by 2, and then you got the moment of inertia of transfer. From here, you're going to transfer this one, okay? Here, you're going to transfer it over there, okay? So there should be D, okay? There should be, okay? There should be D. Ano yung D natin? Okay. What's the D? Okay. From here, over here. What do you think is the distance? If the total is 24 plus 1 and then 1, total here is 12 plus yung kalahati doon ng 1 na 0.5. Okay? That's why you have here the D is 12.5. Area is just 18 times 1. The formula is BD cube. B is 18. This one is B. Okay? D, this is D. Okay. D is the thickness, which is 1. So we calculate this one, multiply by 2. So you can have this answer. Okay. So we're done with 4 angle bars. And then you have also the flanges. Oh no, the web plates, not yet with the angle bar. Next is the angle bar. So with the angle bar, as you can see, I redraw it here. So this is XC, and then you have your YC. According to the problem, X and Y is 1.68, there is 5.75. The moment of inertia is given as well. So we just have to substitute the formula. But we have to compute what is this distance. Okay, this is 1.68. From here is 1.68. So what would be our D? Okay, this here should be our D. Okay, it's 10.32. How it is possible? You have 12. Okay, here this one total. Starting from here, this is 12 going here, right? It's 12 minus 1.68. This one. Okay, the centroid. Okay, the distance from here, from the top here, which is this one. It's either X or YZ. It's obviously it's for YZ, which is also equal to 1.68. Okay, this one is 1.68. Okay, so we can compute D, which is 10.32, and this is the one, 10.32. So area is 5.75. Centroid, it's already given. I'm sorry. Moment of inertia, it's given to be 19.9. We just follow the formula, okay? Ix plus AD squared. So we have this value. So if we already calculated all, you just multiply actually by 4 because it's 4 angles, angle bar. So we computed first the web, next the flanges, the 2 flanges, and then the 4 angle bars. We sum up those, then we can get the moment of inertia, which is equal to 9,230 inches to the power 4. Okay? So any question about this one? You may adjust. Okay, thumbs up. Okay, Mr. Jovito, Happy New Year. Welcome. What else? Okay.
Thank you very much, sir.
Okay.
Same to you.
Thank you. So let's continue. Before I proceed with the rectilinear, I remember this our discussion in the force system, the 3D, 3 dimension. This one is always being given in the board exam as well. So I am going to present this problem. Okay, I hope you could visualize this clearly. These are 3 leg, okay, supporting a vertical load of 2,000 kilonewton. This is 2,000 kilonewton. These are being supported by these legs, this one, and then this one. So at point here, this is A, this one is D. Okay, you have here C, you have here B. Original problem, wala yung makakuha na, yung mga forces na to. But since logically thinking over the figure, you have this 2,000 kilonewton going down. Okay, this one 2,000 kilonewton going down. So this one should prevent from, okay, this one, and then this one should prevent from overturning. So thus this one should compress, this one should pull. So ito ang mga maging forces dito mag-support, going towards, going here, and then here. Okay, also here. Dito naman sa kabila, may tension. So may pull dito sa support. Kasi nga kung ipupush, pwede nag-overturn. The question is to compute what would be the force in each member. So ang tinatanong lang is force of member AD or FAD, if AB and AC. Ito may annotations na ako doon dito. D1 meaning the distance 1 from A to D, distance 2 from A to C, and then distance 3 from A to B. Okay. Okay. So let's analyze. So how are you going to calculate the forces? So we take moment, okay? We take moment at Z. Where is Z? Z axis. Ito yung Z, di ba? Ito. Ibig sabihin, magpapaikot tayo dito. Okay. Pag magpaikot tayo dito, if we're going to rotate at the Z axis, we are going to look at what plane? This Y and X plane. So if I'm going to draw it here. Y and X plane. Okay. Now, this is point D. Okay. And then this point D has a distance over here, which is 20. And then there is another point here, which is point A. Okay. And this one, it will be the leg going here. Okay. The leg. And dito yung load na 2,000 kilonewton. Okay. This distance is also given to be 10, which you have a height given to be 15. Okay, 15 meters. Let's say meters. Hindi na po na-specify yung siyempre meters, hindi centimeter. Okay, so here is this is the y-axis. And then this one is the x-axis. So we are looking actually the xy plane. And z here is going towards us. Okay, so we're going to rotate at this z-axis. So take moment at z-axis. So what are the forces that you can see? Dito meron pababa na dy. Okay, and then you have here to the left is dx. Okay, now very obvious, if we're going to take moment at z, makumpin natin yung dy. Tama ba? Okay, dy times 20, 2,000 times 10, we compute dy. Okay, so with your moment at z, you have dy times 20 minus 2,000 times 10, or all forces in this direction is equal to forces in the opposite direction. It's the same, okay? So, in other words, you compute dy is equal to 1,000 kilonewton. So, what's next? After dy, if we can compute the dy, then we need to compute d1. What is this d1? Ito na yung distance na tinatawag ko d1. d1 is just the hypotenuse of a triangle. Ito yung triangle, ano? Actually, you have here, this one is just 15, slope by 30. Okay? And this one is 30, actually. Here going here is 30. Okay? Up is 15. So we can compute d1. It's just the hypotenuse. Okay? d1 is ito 33.5. Okay? Change ko yung combo. Okay. So by ratio proportion, ano yung ratio ng proportion natin? dy or AD, ano yung AD? This is force AD. Force AD is 2 D1. Ano yung force AD? Hypotenuse yung AD, di ba? Ito yung AD na yan. Ito, mula dito is force AD. Naka-proportional doon sa distance na 1. At saka yung DY naman natin na vertical support along y-axis. Okay? Wala naman ibang one dyan na force na support. Okay? DY is to Y. Okay? So AD, ito yung tinatanong natin. 33.5, ito yung kinumpute natin. And then you have DY, 1,000, na nandito yan. And then 15, yung height. Okay. Anong relation? Kasi ito, 33.5, yung length ng force AD. Ito naman 15, yung height. Okay? Yung height, 15. From this here. Okay, so we can compute AD. So the concept is this one, okay? Similar to the next calculation. So, ito naman, we take moment at x. Ano naman yung x axis? So, pagka Pag mag-take moment tayo sa x, so meaning we are looking in this direction. Okay? Itong paikutin natin na x, okay? So pag paikot natin sa x, we are looking at this direction. In other words, what we can see here, anong plane? Y-axis and then Z-axis. Okay? Yun ang makikita natin. So in similar approach, we can have here, andito yung A, andito sa left yung C, which is 10. Ito yung C, 10 daw ang distance mula dito. Yung isa naman, yung B, sa kabila, 5 lang. Okay? Ito, 5. Ito yung B. Okay? So these are, okay, sorry. Ito yung leg. Okay, ito yung leg. Andito yung force na 2,000. CY here. Itong CY papunta dito. Ano? Ito actually ito lang naman ang concern natin. CY at saka yung BY din pataas din kasi nga support nga siya pag hindi pataas yan, the structure will not be in equilibrium, mag-overturn siya. Kaya when we take moment at x, dito tayo nagpaikot, ano? You have yung 2,000 dito, wala na, hindi na siya hindi na siya ma-consider kasi diyan siya sa axis ng rotation. So by times 5 ito, ano? By times 5 minus cy times 10, or kasi kinonsider ko dito ganito ang positive, ano? Or pwede niyo rin gawin ganito, ano? Clockwise force is equal to counterclockwise. Clockwise moment is equal to counterclockwise moment. Okay? So you have here, you will come up with this value that by is equal to 2cy. So by is expressed in terms of cy, vice versa. Cy could be expressed also into by. Cy is equal to by over 2. But if you are going to sum of forces all in vertical direction, ilang forces ang vertical direction niya? Cy, by at saka itong natabunan na 2,000. At saka meron pa palang dy. Asan yung dy? Ito sa likod, hindi mo kasama sa moment. Papunta dito, ano? Ito. Makikita yan pagka dito ano? Let's go. Makikita siya. Andito yung point D. Okay? But if you're going to take moment here at Z, ito yung D, ano? Pag mag-take moment tayo sa Z, wala namang effect itong force na nandito na. Ano yung force na yan? dy. Pero yung dy na yan, calculated na natin yan in the previous slide. Cy, by, dy. Okay? Since dy is calculated before, which is negative 1, which is 1,000, we can calculate as well cy. Kasi nga by is equal to, by is equal to 2cy. So in other words, makakalculate na natin yung cy, which is equal to 1,000 kilonewton. So, ano nang mga na-calculate natin? Cy, we can have, again, by also. Kasi by is equal to cy. Kung ang cy is 1,000, by is equal to 2,000. And then dito, dapat i-calculate natin. Similar yung kanina. Bakit tatlo ito? Okay? So makikita mo, okay. If you remember yung discussion natin sa 3D force system, madali lang siya matandaan. Ito lang. Itong distance along x na 10, tapos, okay, along z I should say. Or start with the x, which is where's the distance along x? Ito yung x-axis do. So from this one, going here is x-axis, which is equal to 10, ang distance. Y, itong y, going down, which is 15. Okay? And Z going here. Okay? Ito naman, which is equal to 10 also. So in other words, kung ito yung axis, pag i-redraw ko siya, okay? Kapag draw ako dito ng, andito yung 2,000. Ano? Andito yung 2,000 going to this direction. So in other words, meron dito siya na along x-axis, ito yung 10. Along z-axis, 10 din ito. Tapos yung height naman niya is equal to 15. Okay? Ito lang ang dapat na kunin nyo para makompute yung D2. Okay? So we can compute D2. Just the square root of the squares of these three coordinates. Okay? For x, y, and z. Then we can compute D2. By that, we can compute by ratio proportion. Makompute natin ang AD na 1373. So we calculated earlier AC. This is already AC. Nakalculate na natin kanina dito yung AD, and then this one is for AC. This one is AC, okay? Just correct yourself. Correct lang. Ito is AC. AC naman yung kinakalculate natin dito. Now, I give you chance to calculate AB. Okay? Given na naman, AD is na-calculate na, and then the other one has been calculated as well. So, try nyo naman i-calculate itong AB. I'll give you 5 to 10 minutes. Check nyo sa classroom. Try nyo mag-exercise, okay? 5 to 10 minutes. Nandito na yan. Okay. Activity 1. Hindi ko pa pala na share. Open ba yung computer nyo? Should be open. Okay. Activity 1. Okay. Here's activity 1. Click nyo lang. Andyan naman yung one. Okay. Click nyo. Andito yung problem. If BY is 2,000, compute force AB. Okay. Try nyo. Okay. I'll give you 5 to 10 minutes. Try to access this yung Google Classroom natin. Access nyo yung Google Classroom natin. Click nyo to. Tapos andito na yung question. One question lang ito. Ano? You just have to compute force AB. Binigay ko na nga itong BY na 2,000. If BY is 2,000, compute force AB. So madali na to. It will not take 5 minutes. If BY is if BY is 2,000, compute force AB. For Miss Magnolia, share ko sa chat. I shared in the chat room yung one. I shared the link para kasi wala ka pang access sa Google Classroom. Just click this link in the chat, the meeting chat, and nakita niyo ba? Okay. So, bundle na nito kasi given ng BY.